everyone, welcome back to the channel. It's a bone chilling minus 19 degrees Celsius outside, and I received this package via DHL today. Inside we have the Tevo Tornado, courtesy of Gearbest, for an unboxing, build and review. So let's jump right in and open this box and see what's inside. There have been a lot more in the way of options towards the end of this year compared to the year before. There's a lot more competition out there, prices are dropping, and a lot more in variety to choose from, which is great for us as consumers. And the Tornado is just one of those many options out there to choose from that we did not have 12 months prior. So let's dig in here. Right away we have what looks to be an assembly manual. Letter from Tevo. Full color assembly manual with step-by-step instructions here, including software. So this really nice little manual. Normally I'm accustomed to finding an assembly guide on a micro SD card. So it's really, we have a little barcode scanner here that will pull up the online videos, I guess, for the various Tevo products. We have this really awesome build surface with a really cool graphic. Nice color. We got a 3M tape backing on the build surface. The printer is very well packaged. Okay, so we have some accessories here. Putty knife. The two brackets that will hold the two pieces of the printer together once we get to assembly. Some tools. Hardware for our bed. Power cable, and so I'm sent the European power cable. I'm in North America, so this is quite useless to me. We'll see if I have something else lying around that I could use in place of this. So I don't know what to say about that. It is quite useless to me. USB cable, zip ties, full-size SD card. So I'm assuming the printer takes full-size SD card. We'll find out when we get into it. Spare nozzle, and it looks like a spare thermistor. So what else in here? And spare Bowden tube. So let's set all this aside. As again, in this bag is our hardware for our heated bed, our springs, our. Let's set this stuff aside. And this hot come out. Let's get the control box out, I guess, first. We'll take a look at this. So it's quite tiny, and we'll take a look inside because I'm quite curious on how they fit a power supply and all the electronics in there. So we got a couple of quick connects here, just like on the CR10, or on and off. Fan fan on the left side, fan on the right side for venting hot air. We have our USB port and full-size SD card slot right there. On the front, we have a reset button, our speaker, our control knob, and I'm not quite sure what this is over here. Maybe it's for contrast control. We'll have to see. Everything, all the wires come pre-wrapped with this conduit, plastic conduit, and they're all pre-labeled. So let's set that aside. See if we can get the gantry out. Up and out, up and out. Okay, so here's our tower and gantry assembly. We have active filament cooling here, and we have, as we saw on the back of the box, we have a quick connect for our control box. All aluminum brackets. There is this one acrylic piece here, but that's contains our limit switch and stop limit switch, but the pieces that do hold our gantry to the tower are all aluminum. Let's flip it over. Set that like that. So we have the one lead screw for the Z-axis. Okay, so that's our tower and gantry assembly. We have a top bearing here to keep our lead screw in line. So, edit that. Take that out. Now we'll lift this massive piece of foam out of the box. Set that aside. And we have our base. And it looks like there's a test print on the bed. Yeah, exactly, a test print. It's stuck quite well. Again, well packaged. Again, we have a quick connect for the bed wiring to go to the electronics box. Aluminum plate on the front and aluminum plate on the back, and again the only thing that's acrylic are the small plates holding the end stop switches in place. So let's get this box out of the way. That's everything in the box. And we'll set this on the table. Okay, so let's take these twist ties off and take a look at this bed, the setup for this bed. Okay. So we'll flip this over, we'll take a look at this. So this is quite unique. I've never received a 3D printer that has the heated bed already pre-insulated. Let's set that there. So the bed plate itself is really nice. There's no wobble in it. It's a large aluminum plate. It's got a nice design, even though we won't see it. So I'm going to go ahead and clean up here a little bit, reorganize, and then we'll put this printer together and fire it up and see how it prints. before we get into the assembly of the printer, I thought I'd take a quick tour through the internals of the electronics box. When we take a look inside the electronics box, we have the power supply here, which is a 24 volt, 8 amp, which is roughly 240 watts. If we take a look around the other side of the power supply here, you'll see this is where you can change your 110 to 220 depending on your region. Please note that you will have to actually open up the box. There's 6 screws, 2 on the back, 4 on the bottom. If you want to get access to this to change your voltage, because there's no place on the side here to allow you to get in to change that, so you will have to open the electronics box. If you look inside the box here, we have 2 cooling fans. One is push, one is pull. So they're pulling air straight through the box and out one side through the other. If we take a look down here, you can see the model of our board and the Atmega chip that's on the board, the 8-bit Atmega chip. And you can see here there's an MKS base version 1.4 board. A couple other things to note. If you take a look over here, we got a solid state relay that takes our DC current and converts it to AC for our heated silicone pad that is on the bed. And we have our LCD display. There is a right here on the front, that is our contrast control, and you can see the back of your SD card slot there. There are 2 connectors on it, the LCD display, one for the SD card and one for the LCD itself. And that's pretty much it for inside the electronics housing of the printer. We have our switch back here, and there's a fuse built into it. Other than that, besides the solid state relay, there's nothing else out of the ordinary. It's put together very well. There are no loose connections inside here. I've checked all the connections. There's nothing loose or disconnected, so everything's connected good. And yeah, that's the inside of the electronics box. Okay, now that we've taken a look at the inside of the electronics box, I'd like to go back to the heated build plate. We have a silicone pad, and this insulating pad here will help to considerably reduce heat loss. Now that I have the M5 screws in place underneath, I've got one of my side brackets all assembled and ready to go. So we'll just line the T-nuts up there in place, and we'll get the proper Allen key and we'll tighten these up. We need to take this bracket with our end stop, our T bracket. This will go here. There is some room for adjustment here, not a whole lot, maybe 3 or 4 mil, because these holes are slotted. Just to see what I mean here, you want to make sure that T-nut in there, you see that T-nut spitting in there, you want to make sure it turns so that it catches the frame. I find this type of T-nut they're very tricky in catching the frame, and a lot of the time you'll get them where you think they're tight, but they're really just tight to the first bracket they were screwed into. So just make sure all those are tightened down good enough, and we can move on to the next step. The hardware for the bed here. Just going to carefully set those in place. I've raised up the gantry a little bit so I can clear it. Which should be fairly straightforward, given the fact that everything's labeled. Okay, now I just got one limit switch left to connect. I have to turn the printer for that. This is this one right here. I got a little bit of that grease on the bed, some isopropyl alcohol will take care of that. And that's the assembly of the Tevo Tornado. That's it. That's the assembly of the Tevo Tornado. I'm going to have to root through my spare parts and cables, see if I've got a North American power cord. The one they sent me with it I believe is European, and here in North America these are useless. So we have our spare build surface and a few other spare parts. We have some zip ties here. I don't know if I'll need those, and our full-size SD card. It's a nice looking printer. It's got a lot in common with the CR10. It reminds me a little bit of the ANET E10 just because for the green. But there are a lot of similarities between this and the CR10. There are no eccentric nuts on this printer, but that said, everything is tight. There's no wobble to. Okay, with the printer all assembled, let's heat up the bed, then we'll proceed to level the bed, and we'll do up a couple of prints to see how it prints. We're going to set the bed to 60. Always heat your bed up before you proceed to level the bed. Let's see how long this printer takes to heat up the bed to 60 degrees. So it's 5:08 p.m. Let's see how long this takes. We're at 60 degrees, and that has taken 1 minute and 35 seconds. So now we can proceed to level the bed. And what we'll do is we'll home the printer. And then we're going to disable our steppers so we can proceed to move the hot end assembly out. And then we're going to adjust and as I said, this is Not a big fan of this because these screws turn. I should be able to just turn this little nut underneath here, but that's not the case here. I have to hold the screw because the screw wants to spin with it. Okay, so that should be it. Now let's home the bed again. One thing you'll notice, the printer doesn't come with a spool holder, so you'll have to provide your own. If you don't have one, you'll have to rig something up until you can print one with the printer. The SD card that comes with the printer does come with a STL file for a spool holder on this SD card, so you can convert that into G-code and print that. There's a test print on here, as well as a STL file labeled CR10 fan shroud. So that's pretty weird that Tevo Tornado has an STL file on the SD card labeled CR10 fan shroud. And what it is it's the model file for this little fan shroud right here on the filament cooling fan, which I thought was really weird. One other thing I'd like to point out, I'd like to bring you around, everybody around here, and I mentioned earlier that there's some slots on this bracket for adjustment. However, if the bracket is not put on in such a way that it's up as far as it will go, your gantry bracket here will hit this little bracket here that holds your stepper motor in place before it ever touches the end stop switch. So this does have to get put up as far as you can put it, given the range you have there on those little slots. Okay, we're gonna heat up our nozzle, and we're gonna grab a spool holder and a roll of filament, and we're gonna run a couple of prints through the motions on this printer to see how they come out, see how that bed fares out for adhesion, and how it fares out for ease of removal. So I'm going to set my nozzle to 200, and instantly you can hear the two fans inside here come on. So let's get in close here. We can hear that noise. It's quite loud. Quite loud. Okay, so let me grab a filament spool holder and a roll of filament, and we'll set up to run a print. Okay, so I got a couple of spool holders lying around from other builds. So we'll get one of those set up. Try to set this up in such a way that this bed cable doesn't interfere with it. So let's slide this printer forward a little bit. Like that. Okay. It feels a little more premium than the extruder that comes with the CR10, as well as it's not interfering at all with the threaded rod on my Z-axis. Looks like there's still a bit of their white filament in there. So let's go in here and pick something to print. Let's try this one. any model files that, or any models that I print here, I'll put a link to where they can be found in the description. So I've got it set up in Cure to print at 55 millimeter per second, and I've got the heated bed set to 60. Let's take a look here. It is adhering quite well to the bed. I just hope that when it comes time to remove the print that it is easy to remove. Why is he screaming? He's screaming. I'm not going to do. The printer has just stopped mid-print. The nozzle just sitting above the print. So what I might do is I might try to print this model on another printer and see what happens using the same G code, see if it's the printer or something else. I'm going to go ahead and print one of the other files I have on the SD card to see if I get similar results. So let's do that. So I'm getting weird issues with the printer. I went to print another file and the printer actually rebooted. So I have to set up my temperatures again. Let's wait till these heat up and then I'll try another print. But here is my first print, or attempted a print on the printer, and for some reason the printer started acting goofy and it stopped. The print nozzle stopped right here and went from halfway to nothing here on the bar, as if it was done printing but it didn't home or anything. I'm not overly impressed by this print quality. Got some wavy lines here, as you can see. We'll find out if it's the print, this model, or the printer itself when I go to print this next print. So we're ready to go. Let's see if this time around it'll work or if it'll reboot again. So I'm clicking on that dragon and here we go. Printer reboots. Very strange. So I'm not sure why it's doing that, but completely rebooted. So I'm gonna go check out this SD card. I don't think there's anything wrong with it. Computer rated fine, but we'll go check out the SD card and reload the models. It's not a good, so far this isn't a good start to this endeavor. So I'm going to set everything there, and then we're going to take the SD card out. So with our second print I get the same issue. It's the printer stops, the display, the bar is at empty and we're at 0 time, the printer nozzle and the heated bed, the temperatures are off. So the printer has not homed, so it's still in the middle of the print. And of course our nozzle is stuck to the print. Just do that. Now let's remove this. As I said, this bed, the adhesion on this bed is quite good. I do recommend a plastic putty knife to ensure the longevity of this build surface. It is fairly tough to get PLA off the bed. We're going to home the printer. And I think after doing a little bit of research online, I've come up with the solution. Before I go over what I think my solution is, we're going to test it out to see if I'm right. So let's go again for a third time. Let's heat up our bed. Another thing I'd like to point out with the heated bed on this printer, currently we're in the heart of winter here, and the temperatures outside are minus 18, minus 19 Celsius. So in this room, in this particular room here, it's quite drafty in my house, and the temperatures get as low as 13 to 14 degrees Celsius. So given that, and the fact that the bed heats up in a matter of 2 minutes or less, the bed actually heats up faster than the nozzle. It's pretty impressive for the size of this heated bed. So the bed is heated up. I got 5 more degrees on the nozzle, and there we go, the nozzle is heated up. So let's attempt to print this statue again. And the printer is not recognizing my SD card. So, third attempt on this printer. Let's see if the solution. Okay. Third attempt on the printer to get a successful print. Set those there. Okay, so it looks like we have a successful print here. I'll do one more print after this just to confirm what my suspicions of the root cause were. And if that print is successful also, then I know I've solved the problem. Again, this build surface is really good when it comes to bonding the PLA. Too good, in fact. Okay, so let's get rid of our support materials here. And this guy. This tie still didn't work out. So much for this tie. So far so good on this print. So these issues I was having here, where the print would stop halfway through my print. I did some research online, looking around. There were all kinds of posts suggesting various things from firmware on the printer or loose wires inside, but I know there's no loose wires in the printer. And then I came across a couple of forum posts where it was suggested that the SD card that came with the printer was the cause of the issue. So I took the same files I saved on this card and I put them on a micro SD card that I know is class 10, and I put that in an adapter, and lo and behold, failed print with the other card, successful print with the micro SD that's in there now. So if this print works, then I will be quite convinced that it was the SD card that was provided with the printer. In some way, I believe it's not capable of being read fast enough in order to keep up with the printer printing. If I'm wrong, somebody can correct me, but every model file that I put on this card that I tried to print, including these two here, either failed or rebooted the printer entirely. So we'll continue doing some prints with the card that I have in a printer. I'd like to do 4 or 5 prints for this video, and we'll see how those work out. And if I don't get a situation like this reoccurring or the printer rebooting, then I'll be 100% convinced it was this card that came with the printer. So here's our second successful print in a row on the printer. I'm not happy with the quality of these prints, the way they're coming out. I'm gonna, for my next print, I'm going to slow down the print speed. But we are getting some lines here throughout the print, and some waviness. I don't know if you can pick that up on the camera very well, but I'm gonna, for my third print, I'm gonna slow the camera down. The detail in her face is a little distorted. A lot of issues here. So I'm gonna slow the next print down. We'll see how that goes. So there's a 25% speed reduction in my print speed. Let's see how that affects the print quality of this model. Okay, so our second print of the night. We've reduced our speed by 30% here, and here's the original. So let's see if we can make that out. So on the left we have the night printed at 100% print speed, and on the right we have the night printed at 70% print speed. And if we take a look here at their faces, you can tell this night is much crisper. It still needs some improvement, but it's much crisper than this night. And what is very evident is if you take a look at the hilt of the sword, this one here is much cleaner, the print more consistent, while this one is very erratic. Also, if we take a look at the base, details seem to be a little bit sharper on the one printed at a slower print speed, and you can really see the rippling up through here. If we turn them, lot more artifacts in the face of this one again, and the sword hilt on the one on the right looks a lot better. So this one was printed at 55 millimeters per second at 100% print speed on the printer, while this one was printed at 55 millimeters per second but slowed down to 70% of that on the printer. Because I was not happy with the quality of this print. I still think it could be better. Okay, so let's set the printer up for one more print. I'm starting to get a little bit of a bubbly feel here, probably from this pulling up from the plate underneath, from removing the models repeatedly. I'm not sure. I've lowered the bed a tiny bit more so that my prints don't stick so firmly to the bed and they pop off a little easier. Because when you're leveling your bed, if your nozzle is too close to the build plate and you're squishing down your filament considerably with a material like this, you're going to have a very difficult time getting your print off. So let's get the printer set up. We'll set our temperatures. So for the last print, I set my temperature at 60, but then let it cool down while it was doing the first layer. And it didn't seem to affect the print at all. The print didn't come loose. This build surface is very resilient. It holds the PLA quite well. Again, it does get loud for a few seconds initially, but then the fans slow right down. So let's go select the print since we're ready to go now. And we'll do this little dragon with a heart. And I'm going to slow it down a little slower this time. I'm going to go down to about 65%. And we'll see how this print turns out compared to these other two. The little Hitman that I printed out, I did drop him, so I broke his arm and his gun. But he has a lot of weird. He could have been better. I printed at 100% print speed, and just you can tell by like the barcode on the back of his head didn't work out at all, and just too much artifacting in there, and so maybe my print speed was way too high for this model, or maybe it's an issue with the model or the printer itself. On this print, I reduced the speed by 35% to see if I can improve the detail a little further. So far, everything's looking pretty good. Here's my final print on the printer. I had the heat bed off shortly after I started the print, and I did have some side effects there with some of the print lifting. The paws lifted here. I slowed this print down to 65% of my set speed in Cura, and I noticed there's a lot less artifacting. The print looks a lot crisper than the two Knights. It turned out a lot crisper, as you can see, but I did have to slow it down about 35% for that. So the two on the left are printed on the Tornado. The one on the right is printed on the CR10. The very far left one was printed at 55 millimeters per second at 100% print speed. And if you see here, we've got some issues with the face and the sword. The sword's actually a little crooked. Should be straighter than that. We've got a lot of artifacting. If we move over to the second model, you see I printed this one with 55 millimeter print speed, but I reduced the speed down to 70%, and the sword is much straighter and cleaner than the first one. Some artifacting, but much less artifacting than on the first one. And if we move over to the very far right, this model was printed on the CR10. Similar results to the middle model, both printed at the same print speed, 55 millimeters per second, reduced to 70% print speed. On the CR10 version, though, I do have some issues with, if you see here, some layer shifting. So I'm going to have to look at that. My belts might be getting loose, or I might have to turn up the voltage slightly on one of my steppers. This looks like it's on my, this looks like it is on my X-axis. So I don't see it on the Y, I see it on the X. So I'll have to take a look at that. But other than that, both of these models are pretty similar. The face on the CR10 version did come out a lot cleaner, though. You can tell, if I put them close together, you can see there's a lot less artifacting on the face of the CR10 model. But I do have that layer shift issue I have going on all of a sudden on my CR10. This is still not bad for my very first prints on the Tornado. With some fine tuning, I should be able to improve it. And with some further testing, we'll see what results we can get. So again, the model on the furthest left was printed at 55 millimeters per second, 100% print speed, and I got quite a few issues there. You can see the sword is crooked, a lot of artifacting. The middle one, it was slowed down 30%, significant improvements. And the model on the far right was printed on the CR10, and we have some minor layer shifting, but other than that, a lot less artifacting. The face is a lot crisper. But then again, I've had the CR10 for quite a while, and I've just received the Tornado, so this, don't take this as a direct comparison of print to print. I'll have to play around with this printer a little bit more, get a good feel for it to see what I can get out of it. This brings us to the end of my unboxing and build video for the Tevo Tornado. I'm quite impressed with some of the qualities of the printer, to the quick heat up time of the bed, to the fact that we get not one but two premium build services with the printer, which is really nice in and itself given the price point of the printer. Once I've had enough time to play around with the printer, fine tune it, print some bigger prints, some major prints on the printer, I'll be able to formulate a final opinion on the printer. But so far, it's mostly positive. The negatives are very few and far between, and I'm really happy with how this printer turned out. I like the look of the printer. I feel that what I've seen so far, it is a good value for the build area and what you're going to get. So I hope the video was informative. I hope you guys enjoyed the video. Thanks for watching, and I'll see you guys next time.